Hello, everyone. Welcome to PyData Global 2021. I am Conrad, one of the co-chairs for PyData Global. We're very happy today to welcome Chengxuan Wang. He is coming here today to talk to us about FugueSQL. He was previously at Cruise and Lyft, and he's currently working in a self-startup. So thank you. Chengxuan, please take it away.
Sure. Hi, everyone. My name is Chengxuan. So, hello, everyone. My name is Chengxuan. And today I'm going to talk about FugueSQL, an abstraction, an abstract interface for distributed computing. Please feel free to ask any question in the chat. The creator of Fugue is also in the channel. So if I don't say the questions, he can answer as well. So firstly, let's have an overview of Fugue. There are different computing frameworks in the industry, like Spark, Dask, Pandas, and on GPU, it's Rapids and the Blazing Circle. And each has slightly different interfaces. Fugue is an abstraction layer unifying the computation. On top of Fugue, we already have FugueSQL, validation, and tune. Today's topic is the FugueSQL. Let's talk about FugueSQL. If you ever use the SQL in your Python workflow, you will see this common pattern. You write a block of Python code, then invoke SQL, and do something, and get the data frame back and repeat. This code is very convoluted by switching between Python and the SQL. This seems inevitable because Python is the dominant language, and the SQL is not designed to support multiple tasks. FugueSQL solves this problem by adding extra intuitive syntax to the standard SQL, so you can easily describe your end-to-end workflow using SQL as the dominant language. In addition, you can write simple Python function as extensions that can be directly invoked by SQL. Commonly, you will see your code becomes significantly shorter with much better readability. I also want to mention that FugueSQL can use Dask SQL, Blazing SQL, and Spark SQL as the backend. It can also run with, and of course, it can also run without any of them. That's why FugueSQL is very unit testable. Now let's take a look of an example. We want to compute the media of column D of a Pandas data frame, and then get the difference of each D and the median. It's quite simple to express in Pandas, but not easily at all in SQL. So we just write such a function. In this computing example, we will use Fugue on Dask and the Dask SQL. We have two data frames as input, which is the df1 and the df2. We want to join them, get the product of B and C as the column D. We can use SQL here. And then we want to do two things. One is to compute the difference from media for each group. Another is to take the smallest n rows from each group, sorted by B and C. On the left hand, it's how we do it using Dask and the Dask SQL. And we have to write another first n to do the second thing. Now let's take a look at how to express same logic in FugueSQL. We only need, as we can see, we only need a single block of SQL code here. We define and assign the join logic in a way like Python. And to compute the media diff, we can also directly invoke the media diff function. And we don't have to care about the metadata, which is a specific thing for Dask. And to get the first n rows in a group, we don't even need to implement anything. We have the tick keyword to handle that. Actually, tick can be significantly faster than the Python approach in certain execution engines. Also, please pay attention to the engine. Compute 2 is no longer only for Dask. It can run on QDiff and Blazing. It can run on Spark, and it can run without any of them. That's how you do unit test. You also have a lot of flexibility on the input. df1 and the df2 can be Panda DataFrames, Dask DataFrames, or cuDiff. And the engine can be combination of Dask engine plus Blazing Circle engine. So your circle will execute as Blazing Circle, and the rest will use Dask to run distributedly. You will see more details example in the following demo, where we will use FugueSQL on Spark. Okay, it's demo time. So in this demo, we will. So in this demo, I will show how FugueSQL makes SQL as the first-class citizen for data pipeline and the data process. I will use two examples to demonstrate the basic feature of FugueSQL. So just a reminder, there is Spark logic in the demo. But it's only for comparison. It's not necessary to understand the Spark circle here. So let's take a look at the first example. So you are processing a data frame, and here is the business requirement. So the data frame has 4 columns, A, B, C, D, and the types are all string. And the business logic is for any given row, if the number of non-null value is smaller than 2, we drop the row. Otherwise, we concatenate the non-null columns in order, or put in another column called E. And also in the same time, we also keep the original columns. So firstly, let's generate some test data. So you don't need to care about the logic to generate the test data. So let's just take a look at the test data. So as you can see, there is A, B, C, D columns, and also they are all a string and only contain X, Y, Z. But also notice that there is some columns has null value. Okay, so let's see how we can use the FugueSQL to do simple data exploration. So as you can see, we are given a notebook magic called FCircle. So it indicates in this cell, we will use the FugueSQL. So let's say we want to filter out all the rows where the value of column A is either X or Y. So it's pretty easy to express in SQL. So let's do it. As you can see, the result only contains X, Y for column A. So the default backend of FugueSQL is Pandas. So that's the reason. So the output will be Panda DataFrames. But the FugueSQL is not only about Pandas. It also can run any execution engines we like. So if we want to run the same logic in Spark, we just need to specify the Spark at the end, and the end of the FugueSQL magic. And the same with the same logic, we can definitely give the same results. Yeah, let's see. So the results is actually they are the same. So as we also support multiple execution engines. This is Spark, and also we can also run on Dask. Okay, and you may notice that when we run with Spark, but the the type of sample is actually Panda DataFrames. How do we do the conversion? So you don't need to, for FugueSQL, you don't need to worry about that. FugueSQL do the auto conversion for you. So no matter the sample data is Panda DataFrame or Spark DataFrame or Dask DataFrame, it will always works. Okay, so let's go into the business logic. So you may thinking to express the business logic in SQL, you may find that it's quite hard to do that. But by using Python, it's very easy to write. So here is the function, and I think it's almost the most intuitive way and the easiest to read. So we treat the data frame as the iterable of list of values, and of course the output is another data frame, so it's also the same type as the input. So inside for each row in the data frame, we first get all the non-null values, and if the non-null value is bigger or equals to, we yield the row and plus the concatenate of all the non-null values as the new new columns. Because it's very it's plain Python, and so it's very unit testable. So let's firstly we can write a simple test to do that. As you can see, the last rows will be omitted because there are too many nulls. And for the first three rows, it will output another column as the concatenation of non-null columns in that row. Okay, so you may wondering, now let's run it. Like now we want to make it scalable. So we want to make it distributed. So let's first say how can we run it on using a native PySpark. So because a PySpark always take a Spark data frame as the input, so we need to firstly convert the sample, which is a Pandas data frame, to a Spark data frame. And in order to use the circle, the most intuitive expression in circle to do the filtering, we first need to register a data frame into a table. So we use the create or replace template view to do that. Then we apply the circle here. Then we will say we need to use the map partition functions on Spark RDD. Map partition function is a very powerful function, but it only takes the iterable of row as the input type. And this row is execution aware, which is only available in PySpark. So in order to use the concatenator function we defined, we first need to write this wrap function. And inside the wrap function, we need to create a convert function in order to generate the iterable of list of values. In here is A, B, C, D, and then apply the concat. Okay, finally we use the concat function here, but at last we still want to do group by e column and order by the counts of the number in e column. So it's also very easy and intuitive to express in circle, but in order to do that, we still need to use the create or replace template view to register result data frame into a table result. So you may say, so the same pattern happens again. So here is a Python code and invoke a circle, and another Python code and invoke circle again. So it has a lot of boilerplate code I need to write. But firstly, let's run it. So it produces some values here. Let's say let's say how can we do it in FugueSQL. So in FugueSQL we introduced a transform keyword. A transform keyword can use a Python function to do the transformation, because a concat is very hard to express in standard SQL. So we have little help from Python function. So basically we first select to do the filtering, which is very easy to express in SQL. Then also use the concatenator function, which is very easy to express in Python. And lastly, it's also very easy to express in SQL to do the grouping and order by. Lastly, we print. So as you can see, we give the exactly same result as the native Python PySpark code. And of course, we can use different execution engines just by using, for example, here using Spark. We also give the same results. And also this sample is, it's a Pandas data frame. And even though we use Spark, it also can run because we do the automatic conversion for you. Okay, so business requirements always change. So here is the business requirement change. So for this time, the import data no longer have column D. Other things remain unchanged. Let's prepare the data. Okay, there is no column D here, right? So let's say if the original PySpark code can work. So let's run it. So you will see it throws exception because the column D is already gone in the original data. So this means the original wrapper function we write no longer works with the updated data. So because there is no column D, right? So in order to make it work, we need to create another new wrapper to we'll create another new wrapper 2 function, basically to omit the load.d here and apply the same logic. And of course, we always need to specify the output schema explicitly. Okay, so let's say how we do it in FugueSQL. You may aware we didn't change any code in this block other than the input data. This is because in FugueSQL we support the star, the wildcard schema. It means when we do the transform, we use the previous output data schema. If we use star here, it means we just put the input data schema here and plus a new column. So it's because, and also because the concat function, it only takes iterable of list of value. It doesn't aware any of schema. So that's the reason with these two benefits, we don't need to change any data other than the input data. Yeah, so it works as well. So okay, so let's go to a second example. In this example, I will show how to use FugueSQL to do basic machine learning. So we have a pair of train and test data set with partition key on category. We want to train a logistic regression model on training set and do distributed inference on the test set if the test set is very big. So of course, let's prepare some training data and the test data. And let's take a look at the training data. So we have the A, B, C, D, E as a feature column, and also the Y is the ground truth, and yeah, basically the target value. And the category is the partition key. And the train is, it's for training data, it's always true. Otherwise, for test data, it's false. Okay, so let's say how we can do it in local machine. So here is because we already have the training data, and we know ABCD is the feature data, and training.y is the target value. So we can easily train a logistic regression model here and dump into a local storage. And for the prediction function, it's also very easy. We just load the model from the local machine and use the predict function applied on the test data with the feature columns A, B, C, D, E, and generate a PRED, and also append the PRED column to the original test data. Okay, so and of course, because it's very easy to write, let's write a test for it, and we see the prediction here. Okay, so right now, let's say when the test data frame becomes super big, so we need to apply distributed way to do the distributed inference. So let's see how we do it in plain PySpark code. So as usual, we need to convert the original Panda data frame to Spark data frame. And for these two lines, it's basically we want to define the output, the schema of output data frame. So basically, we take all the original columns from the test data and append the PRED column as the prediction. As you can see here, we no longer use the map partition function again, and here we use the map in Pandas. This is because the prediction function takes the Panda data frame, and the easiest way to do to apply the prediction function is to treat it as a Panda UDF. So in order to use Panda UDF, we need to write another predict wrapper because the map in Pandas only takes iterator over Panda data frames, and also because we need to use a parameter in the predictor function, we need to define the lambda here. And this schema is the schema we just defined with predict. And then lastly, we want to calculate the precision, which is the summation of true positive and the summation of all the true values. So firstly, let's run it. But you can see we also need to write some boilerplate code, for example, the wrapper. Okay, so so the precision is 73%. So let's see how we can do in FugueSQL. Actually, it doesn't. Actually, it only needs 3 lines of code. So basically, we transform the test data set by using the prediction function we just defined here. And we also can pass in the parameters. And also, and we don't need to write the 2 lines to specify the schema because we have wildcard, and we just append another paired column in integer at the end. And for the precision calculation, it's also very easy to express in in SQL. So we only need 3 lines. But we also get the same result as the native PySpark code. Okay, so data scientists always need to experiment on different ideas. So this time we may think if we can partition the training data by category first, and then for each category we train a different model. Then we do the inference assembly. Let's see if we can improve the precision. So firstly, let's define two functions. One is the train function, basically use the logistic regression model and to train on the ABCDE feature columns. And also we save the binary of the model into model column. And for the prediction, because the data is already partitioned by the category, and there should be only one model. So we do a validation here, and then we load the binary model into our object, and then do the prediction on the test data. Okay, so because of the partition logic, it's almost very hard to write in Python and standard SQL. But how do we do in FugueSQL? It's pretty easy. You can see we just transform with the training data and the pre-partition on the category. Then use the train cat function we defined here to train on each different category, and also generate the output with schema, category, and the model binary, which match these 2 outputs here. And for the inference, it's also very easy because we provide the zip keywords here. We can zip the models and the data. Since the model has the category as a partition key, and the data also has a category as a partition key, we can just zip them together, and FugueSQL will automatically help you to do the zip. Then we transform the zip the data using the prediction function we defined in Python, and output the data frame. You may notice that the prediction function actually has more columns, but here we only care about the Y column, predict column, and the train column. At last, we use the very easy to express SQL to calculate the precision, because the inference we inference on the whole data, so it has both training data and the test data. So we need a group by here. So this is actually from the precision on the test data. So we say it's 88%. It's much better than the 73%. Okay. So right now, as the data set done the experimentation on small data set, we want to production it on a large data set. Fugue also can do that. We just need to put the the circle into a variable and import the Fugue F circle from FugueSQL call and apply it with the circle. And also we can pass in some parameters. In this case, is the data, and we can run on different execution engines. In this case, is Spark session. At last, I also mentioned that we also have a functional interface. So we also have function interface in parallel with the FugueSQL.
Chengxuan, just a quick thing. You have 5 minutes left, so in case you want to do more of a Q&A, quickly wrap up and do that. Otherwise, also just feel free to just do the whole thing without a Q&A. Thanks.
Yeah, sure. I'll move finish. So we also have the functional interface in parallel with the FugueSQL. So if you more prefer functional interfaces, so you can use the functional interface here. Okay, let's go back to a slide and wrap up. So what's the motivation of creating the Fugue project? In the past, we create our own computing logic to run locally using simple Python and SQL. But in order to scale out, we have to use certain distributed computing engine. In order to use a certain engine, we normally have to adopt their APIs and interfaces, making our core logic convoluted and hard to maintain. So instead of learning and adopting to certain frameworks, how about create an abstraction layer? That's the motivation of Fugue. It's to hide the complexity and the inconsistency of different computing frameworks and provide a unified approach to do distributed computing and machine learning. With this design, since the core logic is written in simple ways, they are already easy to unit test. Plus, Fugue can let you use local execution engine and a mock data frame to run on your data pipeline end-to-end without the Spark and the Dask. So it's very iteratable. At last, and because Fugue is platform agnostic, so it becomes very migratable. You can so your core logic can the Fugue level code can run on Spark, Dask, Blazing without any code change. Okay, all the packages I talked about today are open sourced. For Fugue core and the FugueSQL, please install the Fugue package. And for GPU and the Blazing support, please install Fugue Blazing. Thank you. Oh, I saw the question from Lu Xu. How performance of Fugue handle extreme large import values? So because Fugue is an execution engine agnostic, so if you write your own logic in your local machines, then it can be easily scaled out to a distributed fashion. So I think the performance is very good.
Okay, if we don't have more questions, we're gonna have to get ready for the next talk. Thank you a lot, Chengxuan.
Thank you for your time. Thank you guys.